Welcome back. Now our chemistry webinar will start. The chemistry webinar will be conducted by Dr. Sonia Kundu ma'am, and she will today teach you the lesson on chemical bonding. It is included in ICSE as a whole chapter and CBSE class 10 in a portion of, it's a one portion which includes a metal and non-metal chapter. So this chemical bonding concept is very much necessary for your higher studies and to understand other molecules' behavior to different chemical reactions. So this session will be continued by her. Thank you, ma'am. Please continue.
Thank you, Helendy. Good evening to all my students and respected viewers. So today we will begin with the chapter chemical bonding, as already said by Helendy. So for chemical bonding, we have to know like atoms. First, we have to have a concept about atoms. Now, atoms are just like the people. They don't like to stay alone. So what they try to do, in order to gain stability, they try to bond with each other and they stay stable and happy. So this bonding between atoms is just nothing but chemical bonding, and here in this chapter we will see that how these atoms interact with each other. So moving over to the next slide. So the chapter highlights basically includes the types of chemical bonding. What is chemical bonding? A brief concept about the atoms and the different types of chemical bondings, their definition, structures, some properties of electrovalent bond, covalent bond, coordinate bonds, their comparison of properties, some previous year question answer discussion, and some model or pattern questions for your upcoming board exams. So now, from where did the concept of chemical bonding first arise? Now, at the beginning, as I was telling, you have to have a basic concept about what are atoms. Atoms are basically the smallest unit of matter. It consists of the nucleus and this is the outermost shell. In the nucleus, you have subatomic particles P and N. What is this P and N? Describe. P stands for protons and N stands for neutrons. These protons carry plus positive charge. Neutrons have 0. That means they don't carry, charge is negligible. And in the outermost shell, you have E, which is nothing but electrons. These electrons have negative charge. So, atom as a whole is electrically neutral because the number of protons is always equals to the number of neutrons. So, the positive and the negative charge cancels out each other to make the atom as neutral. So, this is the concept of atoms. Now, these atoms, they interact with each other to form a force of attraction to build together a molecule. This force of attraction between two atoms is nothing but chemical bonding. And as I said that at all, why will they interact? It is because if you have a previous idea about the periodic table, which is also a very important part in the ICSE syllabus, and all these periodic table chapters, if you come from 1st November to our website BookmarksEducare, we will be giving free mentorship where all these chapters will be discussed in detail. But about periodic table, when you have noble gases. These noble gases are helium, neon, argon, krypton, xenon and radon. Now, the noble gases, they are inert in nature. Why inert? Because they have electronic configuration. Helium has 2 electrons in its outermost shell. That means it follows the duplet rule. Neon, it is 2 and 8. That means in outermost shell it has got 8 electrons, so it follows the octet rule. Now whenever in the valence shells you will have 2 or 8 electrons, that means that molecule is highly stable. One is by transfer of electrons and the other is by sharing of electrons. Okay, so now this transfer of electrons and sharing of electrons, this results during the chemical bonding. So therefore, the redistribution of electrons and the force of attraction that is existing between the two atoms, which pulls them together to form molecules, is known as chemical bonding. Now moving over to the next slide. So what is the definition? Quick recapitulation, it is defined as the force of attraction that acts between any two atoms in a molecule in order to gain stability. Now there are three types of bonds. What are they? They are electrovalent bond, covalent bond and coordinate bond. Now here you see a typical cartoon-like picture where you see in case of covalent bond what is happening? Mutually the love is being shared. That means it is occurring by sharing of electron pairs between the two atoms that are taking part, right? In electrovalent bond what is happening? One is giving up the love for the other. That means you have transfer of electrons from one atom to the other. Okay? And the other is coordinate bond. Coordinate bond, what happens? It is the type of bond where sharing is taking place, but here only one atom is giving its electron or electron pair to the other atom. That means both of them are not sharing, but only one atom is sharing with the other. So they cannot have too much electrons, and this too much love is being donated to the other one. Okay, so that the other one and that particular atom also becomes stable. So this is the concept of the three types of bonding. Now moving over to the next slide. It is in details we will be giving you about the electrovalent or the ionic bond. Now this electrovalent bond occurs between elements. Now elements are of usually two types. One is metallic elements and the other is non-metallic elements. What are metallic elements? Metallic elements are basically those elements which have in their outermost valence shells 1, 2 or 3 valence electrons. And non-metallic elements are those which have 7, 6 or 5 valence electrons. So these metallic elements, what is happening? They have, as because they have 1, 2 or 3 electrons, they have a tendency to donate these electrons to the non-metals which have 7, 6 or 5. So this electronic configuration where the outermost shell has 7 electrons, they will accept 1 electron from here, from the metal which has in its outermost shell only 1 electron, and this will then, what will happen? Suppose you have sodium. Sodium has electronic configuration of 11. So if I write 2, atomic number 11, sorry. So 2, 8 and 1. So it will try to have an electronic configuration of 2, 8, which is the nearest neon. Okay, to gain stability. Therefore, it has to lose 1 electron. Similarly, if you take chlorine, its atomic number is 17. So its electronic configuration will be 2, 8, 7. Okay, so it will try to gain 1 electron to results into strong ionic or electrovalent bonds, right? So the metals, what happen? They lose electrons, right? And the non-metals are gaining electrons. Now as the metals are losing electrons, that means they are highly electropositive in nature, and as the non-metals are gaining electrons, they are highly electronegative in nature. So when suppose sodium, it is losing one electron to become sodium plus, right? So this is basically positively charged ion. This is known as a cation, right? Chlorine, on the other hand, is gaining one electron to become Cl minus. So this is basically anion, right? So this Na plus and Cl minus, they combine to give me salt, which is NaCl, right? So you see, as sodium is positively charged and chlorine is negatively charged, there will be a electrostatic force of attraction between the cation and the anion, which will hold them together to give a electrovalent bond, which is the concept or the formation of sodium chloride that we see. So in electrovalent generation of electrovalent compounds, ions play a very important role. So ions are basically the charged particles that are formed by the loss or gain of electrons. Okay. Now you see the definition of the electrovalent bonds. It is the chemical bond that is formed to the electrostatic force of attraction between the cation and the anion. Electrovalent compounds are the compounds that are formed as a result of transfer of electrons from one atom to another atom in the element is known as electrovalent compounds. And what is electrovalency? Electrovalency is the number of electrons that an atom of an element loses or gains to generate the electrovalent bond. Now, what are the conditions that an electrovalent bond will be at all formed? If you know about the periodic trends like the ionization potential, electron affinity and electronegativity, then you will, these three important factors are very important because of for the generation of electrovalent bond. Now, what is ionization potential? It is the energy that is required to knock down electrons from the atom's outermost shell. Electron affinity, it is the affinity or the tendency of the atoms or elements to gain electrons, and electronegativity is the affinity towards electrons. So, for metals, what did we see? They are losing electrons, or they have to lose electrons readily. That means what? They should have low ionization potential. If they have a low ionization potential, that means the energy that is required to knock the electron from the metal, that will be low. So the electrons will be released readily from the metal atoms. So these metals should have low ionization potential. What about electronegativity? For non-metals, what did we see? That they are gaining electrons, right? So they should have high electron affinity, then only they can gain the electron. Therefore, they should have high electron affinity. Okay. Now, if the electronegativity difference between the anion and the cation is huge, then only the pull or attraction will be more to form a stable electrovalent bond. That is why the electronegativity difference between the anion and cations to be high, they should have a large electronegative difference. already discussed, metals of group 1, 2 and 13. They usually combine with the nonmetals of group 15, 16 and 17, which has a tendency to gain electrons to generate ionic bonds. Now this is a quick MCQ for the students that have joined. You please go through the questions that are given here. These are short MCQs, and please give the answers in the comment box till we come back after 5 minutes. So we pause here. The screen is yours, the comment box is yours. So please pen down your answers and we'll be back soon in 5 minutes. Thank you.
Audio on.
Okay, welcome back. Welcome back, students. So, we have got some answers in the comment box. So, I'll just discuss them. So, the first question was state the force that holds two or more atoms together as a stable molecule. The options were chemical bond, centrifugal force, coulombic force, and none of the above. And the correct answer will be chemical bond. As just I have discussed, chemical bond is the force of attraction that holds two atoms together to form ionic bonds or a stable molecule. Now name the charged particles that attract one another to form electrovalent compounds. The options were atoms, molecules, ions, and all of the above. The correct answer is ions, because in electrovalent compounds, as I have already discussed, it is the generation of cations and anions which fall under the category of ions. So these ions interact with each other to form a stable electrovalent compound. Now, electrovalent compounds are formed between metals and metals. No, absolutely false, because it is formed between metals and non-metals due to the transfer of electrons. Next question was, cations are positively charged ions formed by oxidation process. This is absolutely true, because oxidation is a process where electrons are lost. It is due to the loss of electrons. So, you see in sodium, when you lose one electron, it generates a cation. Therefore, you see this cation is generated and this process is known as oxidation. Therefore, the answer is absolutely true. Now, moving over to the next slide. Now, you have to come to the structure of some typical electrovalent compounds. Now, this structure is given by the electron dot structure or Lewis dot structure. Okay. Now, the first compound is sodium chloride. Sodium chloride, as I have already discussed, sodium, it has got atomic number of 11. So its electronic configuration is 281, and chlorine is 17, 2, 8 and 7. So this will try to attain a stable state configuration of this, which is that of neon, and this which is that of argon, right? So, sodium, in the outermost valence shell you have 1 electron, plus chlorine, you have 7 electrons, right? This is the Lewis dot structure representation. So, this 1 electron will be transferred here to generate sodium plus Cl minus. So this forms nothing but NaCl. So this is the Lewis dot representation of the compound, electrovalent compound NaCl. Okay? Is it clear? Now, you see here, as because this is losing electron, this is oxidation process, this is gaining electron chlorine, this is reduction process. So, the formation of NaCl is nothing but a redox reaction. Redox reaction is a reaction where oxidation and reduction takes place simultaneously. So, the generation of ionic compounds or electrovalent compounds can be considered as an example of redox reactions. Okay. So, if questions come in this way, that electrovalent compounds are generated by redox reactions, justified, I believe with the example or representation in this way will give you the answer that yes, it is justified that generation of electrovalent or OH. Now coming over to the next compound, which is magnesium chloride. Okay. Now magnesium has an atomic number of 12. So its electronic configuration is 282. This will also try to follow the octet rule by giving up 2 electrons of the nearest noble gas configuration neon, and chlorine again is 17, 287. So this will become 288. This is that of Rn. So this will accept 1 electron. Therefore magnesium, it has 2 electrons. It will combine with chlorine, can accept 1 electron, but magnesium can give 2 electrons. Therefore it will combine with 2 atoms or 2 chlorines to generate MgCl2. That means this will be magnesium 2 plus 2 Cl minus to generate MgCl2. Got it? So this is the Lewis dot structure of magnesium chloride. Now this is the redox reaction. It's given here. Coming over to the third compound, which is calcium oxide. Calcium is an atomic number of 20. That means 2, 8, 8, 2. And oxygen 8, 2 and 6. So this will be 2, 8, 8. Argon, and this will be 2 and 8, which is neon. So this 2 electrons will be donated by calcium to generate calcium oxide. So this is the Lewis dot structure for calcium oxide. So these 3 are the typical examples that I have shown for the Lewis dot structure of electrovalent compounds. Now moving over to the next slide, the concept of covalent bond. Now we have covered electrovalent bond, we have come over to the next part, which is covalent bond. Now what are covalent bonds? Now from how they are formed. As electrovalent bond is formed by the transfer of electrons that happens between metals and non-metals, covalent compounds are usually formed between non-metals and non-metals, right? Here transfer of electron does not take place, but there is sharing of electrons between the 2 atoms, and the sharing comes mutually. That means both the atoms contribute their electron pairs, and therefore the bond is formed. So this usually involves the sharing of the electron pairs between one atom which is non-metal and another atom which is also a non-metal. Here the atoms mutually shared their electrons in the valence shell to attain a stable electronic configuration. As you see here, water. Water, what happens? You have 2 hydrogen atom and 1 oxygen atom, right? Oxygen has 6 electrons in its outermost shell, and hydrogen has 1 electron in its outermost shell. So what will happen? This has oxygen has 2 electrons shortfall, and hydrogen, this will try to gain 1 electron and reach the, it tries to 1, it becomes 2 and that of helium. So here what will happen, the electron of hydrogen will be mutually shared with 2 electrons of oxygen to form 2 single covalent bonds, right? So here you see, now if you count 1, 2, 3, 4, 5, 6, 7, 8, oxygen in its octet state, and for the hydrogen you have 1, 2, 1, 2. That means the duplet state is reached. Therefore, water is an example of a covalent compound with 2 single covalent bonds, right? Similarly, if you see HCl also, this one has 1 electron and chlorine has 7 electrons in its outermost shell. So chlorine will try to acquire 1 electron and also hydrogen has a shortfall of 1 electron. Therefore, they mutually shared their electron pairs to generate a covalent bond. This is single covalent bond. 1 single covalent bond. So HCl is also an example of a covalent compound. So what is a covalent bond? It is nothing but the chemical bond that is formed due to the mutual sharing of electrons between given pairs of atoms of non-metallic elements. Now depending upon the number of the electron pairs shared, you can have single, double and triple covalent bonds. Okay? And the covalent compounds are the chemical compounds that are formed due to the mutual sharing of electrons that form a covalent bond between them. They are known as covalent compounds. And covalency is the number of electron pairs that are shared with 1 or more atoms of the same or different kind to achieve a stable covalent bond gives me the covalency. Now you see, coming over to, there are 2 types of polar compounds, covalent compounds, One is non-polar covalent compounds and the other is polar covalent compounds. Now what are non-polar covalent compounds? When the shared pair of electrons are equally distributed by both of the atoms, then they give us the non-polar covalent compound. Okay? No charge separation will take place. The molecule is electrically neutral and also symmetrical. Examples include hydrogen, oxygen, chlorine, nitrogen, carbon tetrachloride, methane, these type of compounds. Where you see that equally there is an equal distribution of the electron pairs. But in polar covalent compounds, what happens? That the shared pair of electrons are unequally distributed between the atoms. As the electron pairs are unequally distributed, so then a charge separation takes place. That is, the atoms which attract more electron density towards itself has a slight negative charge compared to the other atom. As an HCl, chlorine atom, as because it has high electron affinity than hydrogen and electronegativity, it will have a tendency to attract the electron pair towards itself. So what is happening? So what is happening? The electron density is being attracted towards chlorine. Therefore, this is acquiring a delta negative charge and this is acquiring a delta positive charge and there is charge separation. Therefore, this is a slight negative and positive charge. There is a technical issue. Please give us 5 minutes time. Sorry for the inconvenience. covalent compounds. Now you come to the structure of some typical covalent compounds. Now first I will start off with some non-polar covalent compounds. The first one is hydrogen. Hydrogen, as it has one electron, electronic atomic number 1, it has one electron in its outermost orbit, so it will try to acquire one electron to reach the stable noble gas configuration of helium. So here this will combine or share their electrons to form the hydrogen molecule, right? So this is the Lewis dot structure of the hydrogen molecule, right? And if you see here, you have one single covalent bond. Okay. Similarly, if you take chlorine, right? Chlorine has an atomic number of 17. So this will want one electron to reach the nearest noble gas electronic configuration of that of argon. So here also it is an example of one single covalent bond. Okay. So if it comes that give an example of a molecule which has one single covalent bond, then it will be either hydrogen or chlorine. Okay. Now if it is a double covalent bond, the example is if you take oxygen. Oxygen has an atomic number of 8, so electronic configuration is 2, 6. It will try to gain 2 electrons to generate the stable electronic configuration of the nearest noble gas, neon. Okay. Very sorry for the inconveniences that are caused time and again, but as because we are coming in a digital platform, these are the flaws that occurs usually in digital platforms. So okay, it doesn't really matter. Come on, back here again on the board. of the nearest noble gas, neon. So oxygen has 6 electrons in its outermost orbit. So here you see, this is an example where you have a double covalent bond, right? So oxygen is an example of a compound, covalent compound having a double covalent bond, right? Now you come to nitrogen. What about nitrogen? Nitrogen has an atomic number of 7, so its electronic configuration is 2 and 5. So it will try to reach 8 electrons, that of neon. That means it will require 3 electrons so that to reach a stable electronic configuration. Therefore, nitrogen is an example of a covalent compound with a triple covalent bond. Is it clear? So if we are asked with, give an example of a covalent compound with one single covalent bond, it will be hydrogen or chlorine. Double covalent bond, it will be oxygen, and triple covalent bond, it will be nitrogen. Now this were the examples of covalent bond that occurs between similar atoms. Now what about examples of covalent bond where it is occurring between dissimilar atoms or elements, like HCl I have already shown earlier, water also I have already shown earlier. I will talk about now carbon tetrachloride. Carbon has 6 atomic number, 2 and 4. So this will also try to reach that of neon by getting 4 more electrons. And chlorine has atomic number 17. Okay. So carbon is 1 CCl4. 1, 2, 3, 4. Okay. This combines with so here you see the dot and cross structure for CCl4, right? So you see here example of a covalent compound with 4 covalent bonds. Okay, so example of a covalent compound with 4 single covalent bond is that of carbon tetrafluoride and also methane. I'm not showing the structure of methane, it is similar. It's an exercise for you, so please do it for your practicing sessions. Now, coming over to just one more structure I'll show, that is that of ammonia. Nitrogen is 7. And oxygen, as we know, is hydrogen is 1. So it will try to acquire that of helium. So nitrogen is 5, right? So ammonia is a covalent compound with 3 single covalent bonds in it. Okay. Now here there is a concept of lone pair, right? In ammonia, what we see after the interaction, there are 1 or 2 electrons left over on the nitrogen atom. So these 2 single electron pairs or 1 electron pair gives me this is known as lone pair of electrons. So lone pair of electrons are that pair which is not shared by the interacting atoms. So in ammonia we have 1 lone pair. Similarly, if you see water, here you will have 2 lone pairs on oxygen atom. Lone pair on nitrogen, right? So these are the typical some structures of the covalent compounds. Now the coordinate bond and the lone pair effect will be taken over by Helen ma'am. So I welcome Helen ma'am on the stage.
Thank you, Sonia. She briefed all the things very nicely, I think. All the students, you understand that very well. Now, this is a very important topic, coordinate bond. So, previously she said about the electrovalent bond, covalent bond. In summarized way, what happens in electrovalent bond? If you are gifting someone, 2 friends are there. One is gifting to other. So gift is totally transferred to the other. So that is called electrovalent bond. Like one is gifting its electron to the other. That means it is losing electron and that atom is gaining electron. The atom which is losing electron, that is oxidation, and that atom which is gaining electron becomes anion, that is reduction. And that losing electron oxidation, that is cation. Now what about covalent bond? In case covalent bond is shared pair of electron. That means अगर few friends खाने जाए किसी are in your syllabus. Actually कभी भी पहले कोऑर्डिनेट बॉन्ड नहीं हो सकता है किसी मॉलिक्यूल में. पहले उधर क्या होना चाहिए? पहले उधर covalent bond होना चाहिए. After forming covalent, this coordinate bond happens. So it is also called dative bonds. So these two typical examples are very important for your board exam. Please be careful and listen it very carefully. क्या होता है? एक होता है water. Okay, what is the covalent molecule? Oxygen has two lone pairs and two single hydrogen bonds. अभी क्या हो रहा है? अगर तुम water में कोई acid डालो, कोई भी मतलब strong acid, HCl, H2SO4, HNO3, तो फिर क्या होता है? H plus जो होता है, so क्या होता है? H plus is electron deficient. अभी water molecule में oxygen के पास दो lone pair of electron है. That means oxygen is electron rich. It will have मतलब ये जो इसके पास lone pair of electron है, ये lone pair of electron ये क्या करेगा? It has tendency to donate the electron deficient proton ion which comes from acid. And this pair of electron which is given by oxygen but shared by both oxygen and hydrogen, by this manner which will form hydronium ion. So you can see that this is the covalent bond with oxygen and hydrogen. This is also the covalent bond with oxygen and hydrogen. But that bond I have given arrow. That is actually coordinate bond, and the arrow is in that way where the lone pair is going. Okay, oxygen is giving lone pair to the hydrogen. That's why arrow is in that direction. But mind it, charge is not neutralized. Charge is there. It is whole positive. This is the formation of hydronium ion. Okay, and this hydronium ion formation is very important for your board purpose. ICSE as well as CBSE. This is very important. So you can check this one. This is the electron dot and cross structure. Here the oxygens are in the electrons which are dot that of oxygen, and hydrogen has cross electron. Fine. So this is electron cross dot structure of water, and from that lone pair to hydrogen and the hydronium ion, the total scenario is there. Okay. Now this is the hydronium ion. Another one is very important, that is ammonium ion. What is that? When ammonia dissolves in water, it forms ammonium hydroxide. And there is a very important question. When ammonia is dissolved in water, जो cation form होता है, उसमें क्या-क्या bonds रहता है? Please describe or describe the structure. In that portion, what will you do? You know the nitrogen has 3 single covalent bond. Beware, it's 3 single covalent bond, and nitrogen has triple covalent bond. These terms are very much confusing. Okay, mark my word. Nitrogen has triple covalent bond and ammonia has 3 single covalent bond. This is ammonia. This is single covalent, single covalent, single covalent. Okay. Now nitrogen has one lone pair of electron. It will give to the again H plus बैठा हुआ है सबके पास से इलेक्ट्रॉन लेने के लिए, because बेचारा बहुत गरीब है, इसके पास no electron, so it wants electron to become to occur duplet like structure helium. Okay, so this again forms, लेकिन इसका चार्ज कोई satisfy नहीं कर पाता है, चार्ज रह ही जाता है. Again the same scenario. This is our ammonium ion. These coordinate bonds are very important. This is very short questions, but every alternate year it comes. Please carefully practice it every day. Now our next section will be continued by Sonia ma'am. Please Sonia ma'am come. Thank you. We're coming within 2 minutes. Thank you. Stay tuned.
Okay students, welcome back. Now we come to the last slide of this chapter, that is the comparison of electrovalent and covalent compounds in terms of their properties. Now this is also a very important part that comes in your board exams, where short answer type questions are very common from this part. Now if you compare the electrovalent and covalent compound in terms of state, where you have bonding, existence and the constituents. You see, bonding in electrovalent compound is ionic type, and in that of covalent compound it is covalent bonds. Existence, the electrovalent compounds, they exist usually as crystalline hard solids at room temperature, whereas the covalent compounds, they exist as gas, liquid or soft solids. Why is it so? Because the electrovalent compounds are formed, as I said, due to charge interactions between the ions. So because there is a high electrostatic force of attraction, therefore the atoms are bound very tightly, and hence they are usually solid in nature. But in covalent compounds, there are weak van der Waals forces that are acting between the two atoms, therefore they are not solids but soft solids, liquids and gas in nature. Now, what are the constituents? The constituents for electrovalent compound are, mind you, ions, and that of covalent compounds are molecules. So, ions, this comes as a very tricky question, like when molecules, the constituents in a covalent compounds are molecules, but that of electrovalent compounds are ions. The next is volatility. Volatility, electrovalent compounds are non-volatile in nature, again because of the strong force of attraction, but covalent compounds are highly volatile in nature. Next is melting and boiling point. This is also a very important question, as why do electrovalent compounds have high melting and high boiling point, or justify the statement that electrovalent compounds have a high boiling point. It is because of the strong force of attraction between the electrovalent atoms that are participating to form the electrovalent compounds that you require high energy to break these bonds. Therefore, the melting and boiling point is high for electrovalent compounds, but for covalent compounds, as the bond is very weak, therefore it requires low energy for the disruption of the bonds. Therefore, the melting and boiling point for covalent compound is low, but that of electrovalent compound is very high. Next is conduction of heat. Heat, metals are, we all know, ions, metals, they are good conductors of heat. So, electrovalent compounds are usually good conductors of heat, whereas covalent compounds are bad or non-conductors of heat. What about electricity? Now, in the solid state, the electrovalent compounds are non-conductors of electricity, but in the molten or aqueous state, they are good conductors. Why? In the molten or aqueous state, the bond is breaking and you are generating free ions. These free ions can conduct electricity freely. Therefore, in molten and aqueous solution state, ionic compounds give very good electric conductivity. Whereas for the covalent compounds in the gaseous and liquid state, they are non-conductors, and also in the soft solid state, they are non-conductors. Because they are electrically neutral, there is charge separation, but they do not generate free ions. Therefore, they cannot conduct electricity. Now, electrolysis. Electrolysis is a process, as we all know. This is also a very important chapter that is there in your ICSE syllabus. And today time is short, as because we are just covering chemical bonding. We will discuss all these chapters individually once you come up to our website from 1st November onwards, where we we are giving you mentorship from 1st November. You will be coming. All these chapters are there in our website. You have to just purchase them. At exciting, we have exciting offers for you. You can purchase them and just carry on your Okay. So as I was telling, electrolysis will also be taken up in our mentorship program. So please visit our website from Monday onwards to know more about the courses that we are offering from 1st November. So for electrolysis in the molten and aqueous solution state, it is electrovalent compounds are highly electrolyzed because they can generate free ions. So they move to the oppositely charged electrodes. But for the covalent compounds in the normal state, they cannot be electrolyzed, but when in solution state, then the polar covalent compounds, they can undergo electrolysis because some amount of charge separation occurs in them. Now solubility, they are soluble in water, electrovalent compounds, but they are insoluble in organic solvents like the nonpolar solvents, benzene, etc. And for the covalent compound, it follows the rule like dissolves like. That is, the nonpolar compounds, they are usually solvated by nonpolar organic solvents like benzene, hexane, and the polar covalent compounds, they dissolve in polar solvents like water and organic solvents like alcohol. So reactions for the electrovalent compounds, they undergo high-speed ionic reactions. For the covalent compounds, they have slow-speed molecular reactions. And for the type of reactions is dissociation, that is when electricity is passed through electrovalent compounds. Then dissociation, electric current. Dissociation takes place and the process involves separation of ions. But for the covalent compound, when electric current is passed, then what happens? It is formation of free ions. Free ions are formed and ionization takes place. So, for electrovalent compound, when electric current is passed, dissociation is taking place, and for covalent compounds, ionization is taking place. Okay? So, this is a brief chart about the comparison of the properties of electrovalent and covalent compounds. Now time for some previous year question answer discussion that comes in boards.
Hand selection.
Okay. The first question you see has come in the year 2025. Draw the dot and cross structure of the following. An ionic compound that is formed when magnesium reacts with dilute hydrochloric acid. So, when magnesium reacts with dilute HCl, I get what? Magnesium chloride plus, right, hydrogen. So, if you balance this equation, it is this. Now the question is the ionic compound formed when magnesium reacts. So between the two products, magnesium chloride and hydrogen, which one is ionic? Magnesium chloride is ionic. So you have to draw the dot structure of magnesium chloride, right? So it's easy, I have already shown magnesium 12, so 2H the noble gas neon. Chlorine has 17, 2, 8, 7. It will try to gain one electron to reach this electronic state of that of the noble gas argon. So magnesium having 2 electrons will react with 2 molecules of chlorine to generate Mg2 plus 2 Cl minus to give MgCl2. Correct? So this is the dot and cross structure of magnesium chloride. Now the second question. The covalent compound formed when hydrogen reacts with chlorine. Okay. The covalent compound formed by hydrogen and chlorine. It is HCl, right? So hydrogen has 1 electron. This will react with to give HCl. Okay? So this is the dot and cross structure of the covalent compound HCl. Next is the positive ion produced when ammonia dissolves in water. Now when ammonia dissolves in water, I get ammonium plus ions plus OH minus, right? So as Helen ma'am has said, this is an example of generation of a coordinate compound, that is the ammonium ion. So the structure will be this is the structure of the ammonium ion that will be formed when ammonia is dissolved in water. Correct? So this question has come in the very recent 2025 year of your boards. Next question is a short, very MCQ type question. In the molecule of water, the oxygen has 1 shared pair of electrons, 3 shared pairs of electrons, 2 lone pairs of electrons and 1 lone pair of electrons. This has come in the year 2024. What is the answer? Oxygen has a water, sorry, oxygen. Water, sorry, it is water. So, water has 2 covalent bonds of the oxygen with 2 hydrogen atoms. So, it has ultimately 2 lone pairs of electrons left on the oxygen atom. Therefore, the answer is C, which is 2 lone pairs of electrons. Correct answer. Next is the draw the electron dot structure of methane molecule and nitrogen molecule. I have already shown this 2 molecule structure while I was explaining. So this is just to repeat. You please practice this. This type of questions from chemical bonding are really very common, and you may expect such type of questions in your upcoming board exams. Next is similarly draw the electron dot structure for the following ammonium ion and the molecule of nitrogen. Remember, ammonium ion I have just now shown. this forms a coordinate compound. Mind it, this is ammonium ion and not ammonia. Ammonia gives covalent compound, whereas ammonium ion is an example of a coordinate compound. And a molecule of nitrogen. Nitrogen is a covalent compound and it is an example of, as I said, it has got triple covalent bond, right? So it has got triple covalent bond and not 3 single covalent bonds. So ammonia, ammonium ion and nitrogen are very confusing. Please be very careful, okay? Nitrogen has triple covalent bond, ammonia has 3 single covalent bond, whereas ammonium ion is totally different. It is an example of a coordinate compound. Next is solid NaCl does not conduct electricity as the strength of the bond is weak, it contains free ions, it does not contain free ion, it contains free ions as well as molecules. The correct answer will be it contains free ions because sodium chloride generates Na plus Cl minus upon passage of electric current. Now these free ions can conduct electricity, therefore because sodium chloride has free ions, it can easily conduct electricity. Moving over to the next slide. Now here comes a very tricky question. See, the electronic configuration of 4 respective elements are given. W is 26, X is 28, Y is 281 and Z is 287. The question is which pair of atoms will form a covalent bond? Mind you, will form a covalent bond, right? You see X. First, if you consider X among these 4 elements, it is already 2, 8. That means it has got a stable outermost valence shell electrons or a stable electronic configuration of that of neon. So, it is highly unreactive. It is an example of a noble gas. No question of forming covalent bond. Next you come, W is 2, 6. That means it has 2 electron shortfall. Y is 2, 8, 1. It has 1 electron in excess. So if this 1 it gets rid from its outermost shell, then it will attain a good 2, 8, that of neon. That means it will become stable. And Z is 2, 8, 7 means it has got shortfall of 1 electron. So it can either get 1 electron or it can mutually share electron amongst itself. So 281, the easiest way will be it will try to, Y will try to donate this electron. So it will reach 2, 8 because in order to gain 7 electrons, it is easier to donate 1 electron. So why no point? As because it is transferring 1 electron, it will come under the category of electrovalent compound, or it can readily form a electrovalent compound as that of a metal. 287 and W is 26. 26, if you remember the electronic configuration, it is same as that of oxygen, right? And 287 is that of chlorine. So both oxygen and chlorine, they can interact with each other to fulfill their valence shell and reach a octet, follow the octet route. Therefore, 2 atoms of W and 2 atoms of Z can easily form a covalent bond. Okay? So, if you see the options, what are they? 2 atoms of W, 2 atoms of X, not the question because X is already a noble gas. An atom of W and an atom of X. This and this, X cannot at all react, it is unreactive because it is noble gas. So B and C options are incorrect. An atom of Y and an atom of Z. An atom of Y and atom of Z is a typical example of, if you remember, sodium chloride, where Y can give up or transfer one electron to Z, therefore to reach a stable state configuration. So transfer of atoms means what? It will generate an ionic compound and not a covalent compound. So it will form a electrovalent bond but not a covalent bond. So this option also cancels. I am left over with the option which is 2 atoms of W. So the correct answer will be option A, that is 2 atoms of W. So students, this type of example is very common in the boards where the electronic configurations of 4-5 elements are given, and you have to answer whether they form covalent bond, electrovalent bond, or what is their electronic configuration, what is their chemical formula. These are very common question of the boards. Next is give a reason for ionic compounds have a high melting point. When I was discussing the property slide, I have already mentioned that from the property section, this is a very common question, that why do ionic compounds have high melting point? It is because of the strong electrostatic force of attraction that occurs between the contributing atoms that you require higher energy to break up these bonds. Therefore, the melting and boiling point of the electrovalent compounds are usually high. Next is ionic or electrovalent compounds does not conduct electricity in their dash state. You have two options, fused and solid. So you have to choose the correct option. Now, electrovalent compounds in their solid state, in their molten or fused states, they generate free ions, so they can conduct electricity. But in their solid state, they have high force of attraction between themselves, and therefore they cannot be broken up to free ions, and so they do not conduct electricity. So the correct answer here will be solid state. Okay? Next is the typical electron dot structure again of methane magnesium chloride. Next is the compounds that does not have lone pair. The compound that does not have lone pair of electron is water, ammonia, carbon tetrachloride. There are three options. You have to fill in with the correct option. Water, if you recall, it has got 2 lone pairs of electrons. Ammonia has 1 lone pair of electron. It is only carbon tetrachloride which has got 4 single covalent bonds, and there are no lone pair of electrons in them. So the correct answer is carbon tetrachloride. Next you see, again that is a typical example of where the electronic configurations are given, and you have to, it is W281, X is 287, Y is 25, Z is 1, and W is 281. So what type of bond is formed between W and X? Now W is 281, X is 287. So this will try to get rid of one electron, and this will try to gain this one electron. Okay? So transfer of electron is taking place, therefore WX, the bond is ionic or electrovalent bond. The next is Y and Z. Y is 2, 5 and Z is 1. Right? So this has 3 electrons shortfall, and this can take up one electron to reach the next, that is duplet state of helium. If you can remember the electronic configuration, so therefore it forms covalent bond. So the bond present between Y and Z is covalent bond. Okay? Next is, what is the formula of the compound formed between X and Z? X is 287, Z is 1, right? So this will just need one electron, this also needs one electron. So how can they, both of them need electron. That means what? They have to mutually share their electrons. So, if they mutually share their electron, what will be the formula? XZ. If you see, this is chlorine, this is hydrogen, and you have HCl. So, XZ is the chemical formula. YZ, Y and Z. This is the YZ to like W and X, sorry.
Select the rubber. Select the rubber. Select the rubber. It's hand. Hand rubber. Eraser. Circle rubber. Circle. Choose the circle. Yes. Now circle.
W and X, it is W is what? 281 and X is 287. So this will also be WX because this will give up one electron and this will take one electron. So this is nothing but sodium, light sodium. This is nothing but light chlorine. So Na forms NaCl. So this will also be WX. Clear? Now, the 12th question is bonding in which of the following involves coordinate bonding? You see carbon tetrachloride, hydrogen, hydrochloric acid and ammonium chloride. Carbon tetrachloride we have already seen, it is an example of covalent compound. Hydrogen covalent compound, HCl is also covalent compound, but ammonium chloride is an example of coordinate compounds, therefore it will have coordinate bonding. Now following some the previous year questions, these are some additional model questions that can alike questions that can come in your upcoming board exams. Like you can get the questions like this, like NaCl is an electrovalent compound. It is formed as a result of transfer of 1, 2, 3 valence electrons from metallic sodium to non-metallic chlorine atom. So sodium transfers how many valence electrons to chlorine atom? It will be 1 because it has 281. 1 electron in its valence shell, so it will transfer 1 electron to non-metallic chlorine atom. Next is calcium oxide is similarly formed as a result of transfer of how many valence electrons from metallic calcium to non-metallic oxygen? It is 2 valence electrons because calcium, so these 2 valence electrons will be transferred to oxygen atom, therefore it is 2. Magnesium chloride also it will be by transfer of how many valence electrons from how many magnesium atoms to how many chlorine atoms, right? So magnesium has 2, 8, 2, 12, right? So it will transfer 2 valence electrons, okay, from how many magnesium atoms? 1 magnesium chloride, okay. Chlorine has 2, 8, 7. That means 1 electron shortfall. But this has 2 electrons extra. That means 1 magnesium atom can donate its 2 electrons to 2 chlorine atoms. Therefore, magnesium chloride is formed by transfer of 2 valence electrons from 1 magnesium atom to 2 chlorine atoms. Clear? Now, identify the compounds that has a single covalent bond. Single covalent bond, if you are asked, example, it can be hydrogen, chlorine, right? HCl. Okay? Double covalent bond, water, 3 single covalent bonds, ammonia, okay, and 4 single covalent bonds, carbon tetrachloride or methane. Is it clear? Give reasons for the following. Ammonia is a covalent compound that does not conduct electricity, but its aqueous solution, ammonium hydroxide, is a weak electrolyte. Why? Ammonia is a covalent compound because it does not have any free ions, so it will not conduct electricity. But in case of ammonium hydroxide, what is happening? It is forming in aqueous solution NH4 plus and OH minus. So these are free ions which can conduct electricity. Therefore, ammonium hydroxide behaves as a weak electrolyte, whereas ammonia does not conduct electricity because it is a covalent compound. A non-metallic atom with atomic number 9 forms a molecule of the same containing a single covalent bond. Atomic number 9 means, say X, it has got atomic number 9. That means its electronic configuration will be 2 and 7. So it will try to gain 1 electron. Okay. So the bond between them will be what? A covalent bond, because say X 1, 2, 3, 4, 5, 6, 7. They will mutually share so the bond between them will be highly covalent in nature because they are mutually sharing their electrons. Next is fill in the blanks with the appropriate words in the bracket. The covalent molecule containing 3 single covalent bonds. What are the options? Water, methane, ammonia. By now, I think I have repeated it how many times I don't know. This is ammonia. It has got 3 single covalent bonds. The molecule of water combines with a dash to form a hydronium ion. It is hydrogen atom, proton, hydrogen molecule. Hydrogen atom means this, proton means this, and hydrogen molecule is this. So, H2O, Helen ma'am has already said, water combines with a proton to give H3O plus. Okay? So the correct answer will be proton. Now the formation of an electrovalent bond between elements X and Y, which are a metal and a non-metal respectively, X of which X and Y is a compound, X is a metal, Y is a non-metal. So X should have dash ionization potential and Y should have a dash electron affinity. So you see it is said that XY is a electrovalent compound. X is a metal, Y is a non-metal. So in order to, if you remember at the beginning of the slides, I had discussed the conditions for forming electrovalent compound. So X being a metal, it should have what? A low ionization potential. So this will be low. And Y being a non-metal, this should have a high electron affinity so that it can gain the electron. So this will be high. Okay. Next is a compound has a formula H2Y. Y is a non-metal. State the following. The electronic configuration of Y. If you can remember, H2Y is similar to that of water. Okay. So if you consider Y to be as oxygen, then Y electronic configuration will be 2 and 6. Okay. So this is valency of Y. It will take up 2 electrons. So the number of electrons that it is taking up is known as its valency. So its valency will be 2. Next is the bonding present in H2Y is covalent.
Yes.
the bonding present in the compound between potassium and Y. Okay, so potassium and Y will usually form a ionic bond. Okay, and the formula of the compound between calcium and Y, this will be, okay. So all the questions, this type of questions are very important, a little bit tricky. Keep cool, keep calm, you can crack it. Okay, so thank you for all your attention. The platform is open, you can interact with us. We are from BookmarksEducare. Today we have come up for the first time with our live webinar series. You can contact us in the given contact number. We have our website. Please visit our website from Monday onwards. You can log in today also, but from Monday onwards our website will come up with all the schedule of mentorships that we are starting from 1st November. Do enroll and stay tuned with us. We have our Facebook and Instagram pages. Please like, share, subscribe our YouTube pages, like our Facebook and Insta pages, follow the, be updated as you all are, everything is in social media, so please follow our pages. Mentorship starts from 1st November, so buckle up your seats and enroll right away, right now. So with this we end up with the chemistry webinar series. From morning we have started and completed successfully with the 3 series. One is biology, physics, chemistry. Now the dais will be open to our last subject, that is physics. We welcome the mentors here, our physics team, who will carry over the next 2 hour session. And again, don't forget to stay tuned with us. Tomorrow we are again coming live at 12 p.m. with similar sessions as we had, back-to-back sessions as we had today. So please stay tuned with us. Thank you, all of you.